So this is your processing the data for the standardization of NaOH, which is the week of October 12th in lab. And I've put some data that a student of mine had a few years ago on this data sheet. Remember, you masked by difference the mass of KHP. You first put the vial with the KHP on the balance, and then you took some out and put it in your Erlenmeyer flask for your titration, and then you remasked it after you had taken out the sample. So the difference between those two was the mass of the KHP that was actually in here in the Erlenmeyer flask. So the couple samples that I bothered to write down were, first of all, the mass of the vial in the KHP was 17.1247, and after the student transferred out some KHP, it was 16.6875, which gave him a mass in his Erlenmeyer flask of 0.4372 grams of KHP. Now to that, of course, he added his 75 milliliters of water, mixed it up really well, heated it until it was all dissolved, and added some phenolphthalein to it so that he could titrate it to a pale pink endpoint. So this was the next set of data he got. He started with his burette at 0.00 milliliters. Notice 2 decimal places, or you lose points for sig figs. And his solution turned a baby pale pink at 21.33 milliliters. So his total, since his initial was 0, his volume of NaOH dispensed was also 21.33 milliliters. So let's figure out these things that we didn't actually measure. All right, and here we go. First of all, we have a mass of KHP, and in order to convert it to moles of KHP, we're going to have to use its molar mass. So 0.4, so this is my calculation, 0.4372. You, of course, should put it nice and neatly down here or something, but I don't have a lot of room. 1 mole over 204.2 grams. And my grams cancel, and this comes out to be 0.002141 moles. Now we had 4 sig figs here, and we have 4 sig figs here. Remember, these zeros are all placeholders. They're not significant figures. So we're going to put those all in there. 2141. Now, if you remember from my pre-lab lecture, we had KHP being a monoprotic acid, which meant, I'm not going to draw the whole thing, which meant it was losing 1 hydrogen. Okay, I'm going to draw the whole thing because it's just irritating me. 1 acidic proton, and we were reacting that with 1 hydroxide to make water, right? So this is a 1-to-1 ratio. So we now have, so this was step 1 to find this guy. Step 2 to find this guy. Sorry, I'm writing it all over the place. We're taking our 0.002141 moles of KHP, and we're going to be multiplying it by a 1-to-1 molar ratio. So 1 mole of hydroxide is used per 1 mole of KHP. So our moles of KHP cancel, and we end up getting 0.002141 moles of hydroxide, which is simply the anion from sodium hydroxide. So we can say the number of moles of hydroxide is the same thing as the moles of NaOH. So we have now shown that, in fact, these two numbers, number 1 and number 2 here, are the same number. So now, the only thing we have left in this column to fill in is molarity. And we have to remember that molarity is moles per liter, moles per liter. So now we have our moles, 0.002141 moles, and we have our volume, but it's not in liters. So it's in milliliters. So we're going to divide that by 1,000. So we divide it by 0.02133 liters. And our molarity comes out to be 0.1004 molar. So this time, 009. Now, to find the average concentration, I'm just going to put another one in here so we can do this the way you will do it. To find the average concentration, of course, you add all three of your molarities together. You add that all together, and then you're going to divide the answer by 3. And what I end up with is 0.1003 molar. Now for the last part, the last step, we're going to be figuring out what the concentration was in the Nalgene bottle. This was the concentration in your volumetric flask that you made by dilution. This is the Nalgene bottle, and that's the concentration of the solution you're going to be using next week. So for this, we made a dilution, so we're going to use our dilution equation. M1V1 equals M2V2. M1 is what we're looking for, that we're unsure of. So I'm going to keep M1 here. Now we used a 25 milliliter sample of this, and I'm going to shortcut and leave it in milliliters. I used a 25 milliliter aliquot and put it into a 250 milliliter volumetric flask. So I took 25 milliliters of my initial and put it into a 250. So my V2 was 250 milliliters. My M2 was what I measured. So this is my M2. So this is 0.1003 molar. Now, obviously, if I want to solve for M1, I'm going to divide both sides by 25 milliliters. And this is why I could leave it in milliliters. Because my milliliters now cancel out. And when I do this math, I find that my original molarity is 1.003 molar. So this is the concentration that would go in here, and this is the concentration that you will use next week.